Degraded. 6 reasons why your professor doesn't think grading is a good idea. Here are the 6 reasons. First, there's a statistical problem. Next, there's a comparison problem, a subjectivity problem, a motivational problem, a body of knowledge problem, and finally, a social norm problem. There are probably more problems that I could talk about, but these are the ones I'm going to talk about in this presentation. Let's start with statistics. So typically, grades are calculated using averages or an arithmetic mean. And anyone who's taken a basic statistics class should have enough of an understanding of statistics to know that there are some big problems with doing this. Let's take a look at this. Here's the formula for calculation of the arithmetic mean, showing adding up all of the x sub I elements of a set, dividing them by n, which is the number of elements in the set, which gives you the arithmetic mean. Now, one of the basic tenets of statistics is that the kind of data you have determines what statistical procedures are applicable to that data. So you can't, for example, calculate statistics on data that don't lend themselves to that type of calculation. To refresh our memory, let's look at the 4 levels of data that we talk about when we talk about scientific observation and calculation of statistics. At the lowest level, level 1, we have categorical data. This is when the phenomena that are being observed are divided into categories. Typical categorical schemes are things like gender, right? So we break things down into male and female. Or let's take another example, a bag of M&Ms. We might categorize M&Ms into color groups. So we might have red, green, blue, orange, etc. like that. We could talk about the numbers of M&Ms that show up in each category. We could talk about them in relative percentages. So there were 43% green M&Ms in this bag. Oh my gosh. But if I asked you to calculate the average color of M&M in a bag, you're not going to be able to do it using the formula for the arithmetic mean, which I showed you a second ago. It doesn't make sense for you to first say, melt down all the M&Ms in the bag and tell me what the resulting color is. That is not a useful or meaningful way to calculate statistics in a descriptive way about M&Ms. So that's categorical data. Level 2, the next level, is ordinal data. Ordinal data is when you have a category and the categories have meaningful rankings, and so you can put the categories in order. Now, if I had colors, red, yellow, green, we wouldn't typically talk about them in terms of green being better than blue or blue being better than red, although you might like those colors better. Those are not universally held rankings, and so we wouldn't use that. With ordinal data, however, the categories do have a meaningful ranking or order in which the categories should appear. So, for example, if we were doing a study of people's satisfaction, let's say satisfaction with your university experience, we could put people into categories of completely dissatisfied, somewhat satisfied, somewhat, and completely satisfied. That's 3 categories, and completely dissatisfied clearly falls at the bottom of the scale, whereas completely satisfied falls at the top of the scale and somewhat satisfied falls in the middle. There's a definite ranking to those categories, but you still couldn't say that, for example, being somewhat satisfied is twice as good or twice as much as being completely dissatisfied. Another example of that is the color scheme that we use for the national security level of alert that we're at. So we have this orange alert, red alert, yellow alert that determines how these security screenings go at airports and train stations and things like that. The level of readiness that our country feels like it has to be at. This cartoon is sort of a play on that in the from a Japanese perspective. If you look at these rankings, you've got green, blue, yellow, orange, red. Clearly, blue is a higher level of alert than green. Yellow is higher than blue. Orange is higher than yellow, blue, and green. And red is higher than any of them. But we wouldn't really say that, when we're at red alert, we're 5 times as alerted or as an alertful state as in green. There's not really a meaningful mathematical distance between these categories, and therefore it's not possible for us to calculate a meaningful arithmetic mean or average of these alert levels. We couldn't say that the average alert level in 2010 was orange. That doesn't make sense based on statistical calculations and statistical theory. So let's take a look at the next level of data. That's interval level data. And this, again, we have categories of observations. The categories are ranked, and now we have a meaningful mathematical numeric distance between these categories. One of the most classic examples of this is temperature. So if you look at temperature, we categorize temperatures according to numbers. We might use a Celsius scale or a Fahrenheit scale or even a Kelvin scale. In the Celsius and Fahrenheit examples, and actually in the Kelvin example, the distance between 30 degrees and 40 degrees is going to be the same as the distance between 40 degrees and 50 degrees. The difference is 10 degrees. With interval level data, because we have meaningful mathematical distances between the categories, this is the first level of data at which we're able to apply the statistical procedure of the arithmetic mean. We can calculate all of the temperatures in the month of December and come up with the average temperature of December was 37 degrees and have that be a meaningful number about which we can make decisions, about which we can make predictions. We can use that in a meaningful context when we are doing scientific analysis of things. Now, one of the features of the interval level scale is that there is no 0 point. Now, I know Celsius has a 0 and Fahrenheit has a 0, but those are actually arbitrarily selected 0 points. If you wanted to talk about temperature with absolute 0, you could talk about it in the Kelvin scale, but unless you're a physicist or a chemist doing calculations that require using a Kelvin scale, most of us talk about Celsius or Fahrenheit. And in those cases, saying that, for example, 80 degrees Fahrenheit is not twice as much as 40 degrees Fahrenheit. What's half of 20 degrees is not half of 40. 90 degrees is not 3 times as much as 30 degrees because those distances don't have that kind of interpretive ability. You can't talk about categories that way with interval level data. You can't begin to talk about that until you get to the fourth level of data, which is ratio level data. And ratio data is very similar to interval level data. It's categorized. The categories have definite ranks. The ranks have meaningful numeric distances between them, and there is a 0 point. And so an example of a statistic or a measure or observation that matches up to the level of ratio data would be age. You can have a 0 age, and less than 0 age doesn't seem to make sense. The distance between 1 year and 2 years is the same as the distance between 2 years and 3 years. That's a year difference. And you can talk about average ages. Another example we use is weight, right? You can have a 0 weight. You can have someone who weighs three times as much as another person, and those interpretations of the data make sense because they are at a ratio level. So the question now becomes, at what level of data is a grade? So we collect grades all the time. Sometimes you get a check or an X or a check minus. Sometimes you get have a pop quiz where you can, it's scored out of 10 points. Sometimes you have a test where it's scored out of 100 points. So let's take the example of a test, or even the semester average that you typically get where it's scored out of 100 points. Now, what level of data is that? So the initial reaction is to think, well, that must be ratio level data because you have a scale from 0 to 100 and it has a 0 point. But it fails to meet one of the very important criteria of ratio level data is that the distance between the ranked categories is meaningful. And that would mean that the distance between a 40 and a 45 is the same as the distance between a 45 and a 50. So let's take a look at a typical breakdown of numeric grades. Typically, we rank A's at the university level as 90 to 100 points, B's as 80 to 89, C's as 70 to 79, and so on. Well, now one of the things that immediately jumps out is that the F category is 60 points, whereas all the other ones are 10 points or 11 points for the A category. So the range of F scores is actually 6 times as large as the other ones. It makes it very difficult to make a claim that an 80 is twice as good as, say, a 40, right? If you got an 80 and a 40, there's no way that you would think the 80 was twice as good. You might think 80 is a B is twice as good as a C, or maybe, but you wouldn't really necessarily think of it as being twice as good as a D. And talking about twice as good, 3 times as good, those sorts of descriptions of grades don't really seem to make sense. I use this example to demonstrate that I don't think grades are ratio level data. I think grades are actually ordinal level data. And if you recall, ordinal level data is not subject to being able to calculate an arithmetic mean. You can't take an average of values that don't have a meaningful numeric distance between them. You can only calculate averages when you have ratio level data or interval level data. If grades are actually ordinal level data, then the arithmetic mean is not an available statistic, and it should not be used to base decisions or otherwise do analysis of people who are in a learning process. Now, that being said, there are organizations, for example, the Educational Testing Service, who go to great lengths to ensure that the scores on their tests, for example, the SAT, are meaningful. So the SAT has a scale of from 200 points to 800 points on each of these sections of the test, and you can rest assured that the distance between a 350 and a 400 is the same as the distance between a 400 and 450. I did an internship at ETS one summer when I was in grad school, and I spent a lot of time with the people who do those calculations, and you'd be amazed at the sophistication and the rigor of the statistical procedures that they apply to make sure that the test questions that are used on the SAT, the GRE, and the other tests that they publish live up to very, very high levels of rigor. One of the ways that they do that is that every time they give a test, the questions on that test have been tried out in a non-testing situation. So one of the sections on your SAT is always a quote-unquote experimental section. And those are questions that don't count towards your score because they haven't been thoroughly vetted yet. And what ETS does is they put those questions out there, they see how people respond to them, and then they pass them through some very sophisticated statistical tests to see if those questions really are measuring what they think they're measuring and measuring them at the accuracy they think that they're measuring them at. For example, one of the procedures that they use to develop what they call an IRT score requires that they have between 500 and 1,000 responses on each question before they can determine its relative level of difficulty relative to all other questions. Once you've done that, then you can, with confidence, begin to talk about those scores as being comparable and meaningful. But in the typical classroom situation, first of all, not only do most faculty not have the level of sophistication necessary to do these sort of psychometric analyses, but second of all, we don't have the time or energy to put together tests or the resources to give our questions out to 500 to 1,000 respondents to get this sort of data back that would allow us to say that our test questions are, at an interval or ratio level of scale. And this is a big problem because we typically treat them as if they are, even when they aren't. When you think about a test and you think about those 100 points on the test, how are those 100 points assigned? Typically, and this is probably not unusual, your professor says, well, let's see, we studied 4 units over this period of time, and so I'm going to have 4 sections on the test, and each section will be worth 25 points. But there's not really any way to say that, for example, the concepts in section 1 are exactly the same weight as the concepts in section 2. If you get down to the question level, some of the questions are, say true, false, that are worth 2 points, or maybe an essay question that's worth 15 points. But you really can't say that that 15-point question is worth 7.5 times, or 7.5 times as important as the 2-point question. The numbering systems that we use for grading tests are pretty much arbitrary, And when you look at it at that level, it's pretty clear that the data we have is actually at an ordinal level. And so the A, B, C, D, F categorization of grades that we have turns out to be an ordinal level scale, and therefore the statistical problem is that averages are not supposed to be an available statistic for doing the kind of analysis that typically goes on in a college classroom. Which brings us to the next problem, and this is with grading scales. This is taken from a paper by Vickers from 2000. It's called Justice and Truth in Grades and Their Averages, and it was published in the journal Research in Higher Education. I recommend that you go grab a copy of this article off of Google Scholar and read it. I think it's very accessible, and you'll find it to be pretty interesting. I certainly did when I read it. This table is taken from that paper, and basically what the author is saying is that grades have a basic problem, which is grades don't give you any information about things like the difficulty of the class or the difficulty of the curriculum which is followed by a student. So for example, if you've got a student who takes a whole bunch of easy classes, the easiest classes they could possibly find, does their 4.0 represent the same level of academic ability, of work ethic, of discipline as someone who takes all difficult classes and maybe gets a 3.2 average? I think you would say that no, that's not the case. The other thing that GPAs mask is the number of courses you've taken. So, for example, you could have a 4.0 after having taken your first 3 classes at university, much more difficult to maintain after having taken 30 courses. But another problem, and this is the one that's highlighted in this table here, is that those A's, B's, B pluses, C minuses, all of those different grades get calculated into GPAs in different ways at different colleges. At some places, like on the left-hand side here, there's several different scales that are in use today at various universities. One is the partial CGU 8-point scale, and this is where they take grades on I believe it's A plus, A minus, B plus, B minus. They created an 8-point scale, and the total average you can get is somewhere around an 8.0, I believe. The CGU ramified 4-point is another one. Then you have a 4-point, 5-point, 6-point, 7-point, 8-point. All of these are different ways to calculate GPA. And they give different weights to the different grades. So let's take these two students, Justine and Maurice. These are in columns 2 and 3. Justine takes 3 courses. She gets 2 A's. In the paper he called it E, but for our purposes, just assume that that's an F. Justine got 2 A's and 1 F in her 3 courses. And then you have a student, Maurice, and Maurice took the same 3 courses as Justine, and he got C's in both of them. Now the question is, who's better, Justine or Maurice? Who has actually worked harder? Who has learned more? Who has performed at a higher level? If you look at the calculation of GPA, which is how typically employers and grad schools and other people tend to categorize you, the partial CGU 8-point scale, the top 4 actually scales show that Justine is better. In all of those cases, when you calculate the GPA using their formulas, Justine shows up as better. However, when you get to the 6-point scale, Maurice's 3 C's actually come out to the same GPA as Justine's 2 A's and 1 F. And in the 7 and 8-point scales, Maurice's 3 C's actually put his GPA higher than Justine's. Now, if you've got 2 people who have gotten, essentially the same, who've done the same in 3 courses, you would expect that if there's any way to rank them, that would always come out consistently. And the fact that it doesn't means that the grading scale and the GPA scale actually is less reliable the more courses you add to it. And this is all filled out in much more detailed perspective in this paper. So I highly recommend that you read it. But this is a problem when you begin to compare students based on GPAs. You run into a problem of basic justice and fairness with respect to how those comparisons are made. Which brings us to another problem, the subjectivity problem. And this is taken, I want to talk about a study done in 1974 by someone named Degraded, who wrote a paper called Measuring Growth in English. Actually, it was a book that they wrote called Measuring Growth in English. What Degraded did was pretty fascinating. Degraded took 300 essays that were written by college students and gave those essays to 51 people to grade, 51 professors, and said, on a scale of 1 to 9, 1 being the worst and 9 being the best, how would you rate each of these papers? So the 51 faculty members read each of the 300 papers that were read by the students and graded them, giving them scores from 1 to 9. Degraded was fascinated to find that over 100 of the papers, 100 out of the 300, so a full third of the papers, received every ranking. That means out of those 51 people would read a paper and some of them would give it a 1, some of them would give it a 2, some a 3, some a 4. Every category was used to rate the quality of these papers. Not only that, but if you extend it to papers that receive 7 or 8 or 9 of the available categories, over 90% of the papers received at least 7 different rankings from the 51 faculty. What that means is that there is absolutely no consistency among faculty and how they rate the exact same work. If you think that when a professor comes into their office with a stack of essays or labs or grades or tests to grade, that they give the same level of scrutiny to the first one as they do to the 31st one or the 50th one, you got to be kidding yourself, because people get tired, other things come in, your understanding of quality changes over the course of doing the grades. And even though some professors are very religious about removing students' names from their work when they do the grading so they won't be biased by knowing who the actual student is, not everyone does that. And sometimes professors see a student, and professors are only human. They see a student's work and they say, well, I like this student, and even though they didn't do as well as maybe ordinarily I would assign them a grade, I like them, so I'm going to give them the benefit of the doubt on this question and give them a few more points. This definitely happens, and because of that, since grades are so subjective, they cause all kinds of problems, and you spend lots of time, faculty members spend lots of time negotiating with students over whether or not to get a higher or lower grade, and that's pretty sad in my opinion, because guess what? We have all these discussions about what grade you should get, but we don't spend the same amount of time and energy talking about the stuff that's actually, we're there to learn. We don't spend the same amount of time debating the merits or the quality of the material, or the interestingness or the applicability of how the material is being used in our everyday lives, and that's a problem. And so the subjectivity problem is a real issue with grades, which leads to the next problem, which is the motivational problem. Our good paper to read in reference to this is this D.C. Kessner and Ryan paper from 2001 called Extrinsic Rewards and Intrinsic Motivation in Education, Reconsidered Once Again. It was in the Review of Educational Research. What D.C. Kessner and Ryan did was to do a meta-analysis, and that's basically a study of studies. They went out and got all of the studies that looked at the role of tangible rewards in the grading process. Now, tangible rewards are things like good grades, there are things like stickers, there are things like free meals at McDonald's, things, pizza, any tangible reward that you might get in exchange for having done a quote-unquote good job on some sort of educational task is a tangible reward or an extrinsic reward. And what they found is that there was a negative 0.47 correlation between the use of rewards and students' motivation or interest in the subjects being studied. What that means is the more students rewarded, the less they were interested in the things that they were studying. Grades are definitely an extrinsic reward. They don't have necessarily anything to do with the content that's being studied. They're used as a carrot or a stick in order to get you to do something that you might not otherwise do. But grades introduce a number of other problems from a motivational perspective. The first one I want to look at is the relational problem. Grades rupture relationships. Here you see one student who's clearly cheating off of another student's paper. In an ideal setting, right, cheating would be such a nonsensical thing because, why would you want to cheat on a test unless the test was, directly related to something like a grade or a reward. If you're only after the reward, then you don't care about what's on the test, and you'll do things that are unethical or dishonest, like cheating. However, if there is no grade, then what's the point of cheating? I mean, if I didn't know the answer to this question, I didn't know the answer to the question. That's all there is to it. And it doesn't have anything to do with any rewards or punishments that I may or may not receive as a result of my poor performance on a test. At that point, the test or the assignment really is only a piece of information. It's a data point for me to use to know how I'm doing in a particular class. Grades also influence the relationships between faculty members and students. One of the big problems with grades is that students are so afraid of demonstrating their lack of understanding or lack of competence to a teacher for fear of getting a bad grade that they don't let the teachers know when they don't understand something. And so you get to the end of the semester and the student says, well, I was really having trouble and I didn't understand this stuff, and the professor said, well, why didn't you come to me? I've had office hours and I've been here and available for you. And the students, well, I don't know why I didn't. But one of the reasons that research has turned up is that students are actually afraid of letting faculty members know that they don't know about things, or they don't understand, or they're frustrated or stuck. And to the extent that grades get in the way of a really strong relationship between the faculty and the student member, I think that they're unhealthy. The next problem that comes up with grades is grades inhibit risk-taking. If you've ever had a student who asked, if you've ever heard somebody, or if you've ever asked, is this going to be on the test? Really what the students are asking is like, do I have to know this? Do I need to expend energy in studying this material? Of course, this pisses off professors to no end. Like, well, why would I, from the professor's perspective, why would I spend time working on this in class? Why would I make an assignment? Why would I assign a chapter if I didn't think it was worth knowing? If I didn't think it was going to enrich your study of the particular subject we're studying? But students don't want to take any risks. They don't want to take any chances that they're going to miss getting the things that are going to be on the test, or they're going to, that they're going to be graded on. And therefore, they're not going to take any risks. They're not going to, say, for example, take the risk of reading a different chapter or of taking a different approach to solving a problem. They're pretty much going to solve the problem the way the professor asked them to, regardless of whether that style of problem solving actually fits their cognitive processes or their style of learning or any of the other things. And so another problem with grades is that they inhibit students' ability to take risks and to do really creative work. The reason I bring up creativity is because when you think about things that are truly creative, things that are novel, the definition of novel is it's never been done before, or if it's never been tried that way before. And students are not inclined to do things in a new or novel or creative way because they fear that the instructors won't like it if they try it that way. And so they want to stick to the tried and true. They want to do it exactly the way that the professor says. And they want to, so they're going to color in the lines. They're not going to go out. They're not going to think outside of the box. And that's really a problem because we need people who can be creative, novel problem solvers in today's society. And so grades, to the extent that they inhibit that, are a bad idea. And the final motivational problem is that grades undermine interest. I think you may have heard me say this before, but I consider myself as your instructor to be kind of like a physical trainer. I assume that you're coming to me. You're paying me to be in your classroom ostensibly because I have more knowledge and experience in the topic, and I'm able to help you navigate this material, this new material, in a way that will be the most productive and the most fruitful in terms of your learning and your learning process. If you're doing it for grades, then you're not doing it. Then it becomes not about the learning, and your intrinsic motivation goes away, and that's a real problem because really more than anything else, I as your instructor want you to get excited about this stuff, want you to see how it can be useful in your everyday life and how it can, really, enhance your experience with the world and, enhance your ability to make changes and to do things that are positive and beneficial to the society. Which brings us to the next problem, which is the body of knowledge problem. In this picture, let's assume that the big blue circle is the universe of knowledge that exists in a given topic area. I tend to teach programming and web development, so let's say that this big blue circle is everything that one could possibly know about programming. The little green circle, that's what we're going to study this semester. Let's say that that little green circle is the list of learning objectives on our syllabus. Now, that little green circle could have been somewhere else within our body of knowledge. It could have, contained a different set of knowledge or concepts. There's lots of different things we could have studied this semester, but, I as your instructor chose what was inside that green circle, and I probably chose it for various reasons. One might be that, the stuff that I put on the syllabus is, generally agreed upon by all of the people who do this kind of work to be the most important knowledge. It could be that I chose the stuff in the green circle because it's stuff that I like or the stuff that I know. Take programming, for example. I tend to teach these introductory programming classes that use Visual Basic. But we could teach a class that used Java or Python or JavaScript or any of a number of programming languages that are out there. And in all of those cases, the green circle would move slightly because we'd be covering a different body of knowledge. It's not really important what is in that green circle. What's really important to me is that once you get to the end of the semester, that you still want to learn more. And that's what those orange arrows represent. Those represent the motivation to go out and improve your knowledge and to learn more about the stuff even after the end of the semester. And if you've ever gotten to the end of a course and said, thank God I never have to study that again, that for me is the worst case scenario. That is a scenario when the learning process has absolutely failed. And so it's not so important to me as an instructor what we cover in that little green circle. If you want to draw your green circle somewhere else, that's totally fine with me. What I want is for you to be engaged, for you to find the content to be enjoyable, to be challenging, to be relevant to you, to be meaningful to you, and for you to feel like you're making successful strides at learning the things that you want to learn. So these are the first 5 problems with grades, and so the solution that I've come up with as an instructor is to try to minimize the influence of grades on your learning process as much as possible, and therefore get rid of them altogether. Well, not quite altogether, and that's because of the last problem, which is the social norm problem. Every year, JMU graduates, several thousand students, and those students go out into the world and they apply for jobs, they apply for grad school opportunities, and one of the things that people tend to ask for is a transcript, and they want to see your grades and your GPA. Our society uses those, even though many of us know that they don't really have any statistical validity, that there are huge problems when you try to compare one transcript to another transcript because they really don't match up. There's big problems when it comes to those grades and that GPA having undermined your ability to think creatively, having undermined your intrinsic motivation in learning new stuff. All of those problems, notwithstanding, society still demands that we give you grades at the end of the semester, and JMU breathes down my neck if I don't turn my grades into the registrar by the appointed time at the end of the semester. That's a problem that I'm striving to work at. Obviously, I'm only one person, and this is not something I think I can solve from the top down. I have to work bottom up. So that the extent I can, I'm working to get you to forget about grades while you're in my class. But at the end of the semester, we do have to tell something to the registrar, and that's why we'll be using a portfolio-based design for the class. So this has been Degraded, 6 reasons why a professor doesn't think grading is a good idea. I know that I may have stumbled through some of the explanations of these things, but I provided links to some important papers and some good resources, which I think, if you read them, will really open your eyes to a lot of the issues and problems that come with trying to use grades to measure learning. Thanks.